Alright. Unfortunately, the program crashed the first time I tried to do the voiceover on this, so doing it all over again. Should run through pretty quickly. Just kind of writing down all of the sine, cosine, cosecant, secant, cotangent, kind of all the formulas. H, O, and A all stand for opposite, adjacent, and hypotenuse. So in this first problem, we have to go through and find the hypotenuse. So we use the Pythagorean theorem, a squared plus b squared equals c squared, where c is the hypotenuse. So we're trying to solve for that. So pretty straightforward. Now we have the opposite, the adjacent, and the hypotenuse. We can just go ahead and plug that in to all of those right on up there. Very straightforward. Okay. So I'm not going to go through and write all those. You can just kind of plug wherever you see O, plug 15. Okay, so we have this triangle here. This time we need to know the hypotenuse, but this time we have the hypotenuse, so we're trying to solve for that side. So we plug in 4 and 7 as A and C in the formula, and we find that our other side is square root of 33. So now I go through, and anywhere that they have alpha, I've put in as red, and anywhere that they have, beta, I've put in as blue. Okay, so the sine of alpha, the red one, sine is what? Opposite over hypotenuse, so that would be 4 over 7. Anyway, we're going through here and just kind of filling in. Now that we have all of the sides, we just need to know, what we need to put where, right? Secant, the formula for secant is hypotenuse over adjacent. So we look at the red angle, we look at the hypotenuse, and we look at what is the adjacent one. So anyway, onward and upward. All right, here we go. Going to go ahead and jump into number 24 here. This one's also pretty straightforward, just kind of solving for the missing sides, etc. So they gave us that the cosine of theta, so I've put theta as blue. The cosine of the blue angle is 12 over 13, so that means the adjacent is 12 and the hypotenuse is 13, so that's why I've drawn what I've drawn there. And now I'm solving for that other side. I use the Pythagorean theorem to solve for that other side. So the other side we figure out is 5. So now we go through and just write all of these out, right? We have sine, we have tangent, and now that we have all of the sides, we can just plug in what corresponds, right? So tangent is opposite over adjacent, right? So we take the opposite, which is 5, and the adjacent, which is 12. This is cosecant, right, which is hypotenuse over opposite, etc., etc. So we're just plugging in the sides there where they correspond. All right. Oh, I think I made a little mistake. That's supposed to be a C. CSC stands for cosecant. All right, number 29. So on the unit circle, this one, it's not too bad. Without a calculator, you're just using your unit circle, okay? So you'll look up on your unit circle wherever pi over 6 is. Okay, so you look up on the unit circle wherever pi over 6 is, and then what is the terminal point at pi over 6, right? It's radical 3 over 2. Well, that first number there is the cosine, and the second number there is the sine, okay? So if they want to know the sine of pi over 6 plus the cosine of pi over 6, you're literally just taking radical 3 over 2 and adding that to 1/2. So that's what I do below here. Okay. And then we just replace those. When I replaced them, I think it did it like opposite, right? I like switched the sides. That first number, if we're corresponding, sine of pi over 6 is actually 1/2. Cosine of pi over 6, radical 3 over 2. All right. Good deal. So pretty similar with this next one. Instead of radians, we have degrees now. So we're just looking up 30 degrees and 60 degrees on the unit circle. So I've put their terminal points here, what they correspond to. Okay, so radical 3 over 2, 1/2, and then the other one is the switch version of that, 1/2, then radical 3 over 2. Okay. All right, so then we have the sine of 30 times the cosine of 60 And so we're just going to go through and replace those, right? Because that first value is always the cosine and the second value is always the sine in our terminal point. So the sine of 30 is 1/2. The cosine of 60 is also 1/2. Then the sine of 60 is radical 3 over 2, and the cosine of 30 is radical 3 over 2. Okay, so we put that together. 1/2 times 1/2 is just 1/4, and then we add radical 3 times radical 3 is radical 3 squared, which is just 3. And then 2 times 2 is 4, so 1/4 plus 3/4 is 1. Cool. All right, so for number 39, we just have to find all of the sides and the angles, okay? So we have to find all of our sides and all of our angles. Not too bad, not too tough. So we're drawing out our little triangle here, labeling everything. That's a right angle. So all of the angles in any triangle, they always add up to 180 degrees, right? So if we know we have a right angle, that's going to be 90 degrees, and we know that our other angle is 52, well, what else do we need in order for it to add up to 180, right? So that's all I've put in here. So that helps us solve for that other angle. So I kind of erase this triangle to redraw it here a little bit bigger so that I can put everything in there. Okay, so we label everything. That's our right triangle. That right there is 52. They gave that to us, and then we just solved. Oh, they also gave us that that's 35. And then we just solved and found that that other angle is 38 because that is the missing piece to get up to 180, to get all the angles to add to 180. And now I'm using the law of sines, and in the next page I explain the law of sines. But the law of sines basically says when you have a side and the corresponding angle, you can use that as a ratio for another side and corresponding angle. So then you just go through and solve, kind of plug stuff into your calculator and so on. Okay, so we're getting to our last couple problems of this video. Number 47, again, law of sines stuff. So I go through and kind of explain the law of sines right here. And I label everything. So if we have a side length A and a big angle A, they're corresponding, we can set up these ratios here. And that allows us to solve for a lot of unknown stuff that we're looking for. Okay. So all of these ratios are like equal to each other. Okay. So we can use that information with this number 47 here. We draw out this big triangle and we split it in two. We have like two separate triangles kind of with right angles down there at the bottom. And so what I do is I split this up into like x1 and x2, okay? So we split those up and we'll add those together at the end to get that big side, but we want to find them individually first. So they gave us, we actually just solved, right? Because that bottom left is 60, so that means the top left has to be 30 with the, adding everything up to 180 thing that we talked about before. So we have 60 here, 90 here. That means this has to be 130. That's how I got that. And that means this has to be 60 with all of these angles in there. So then I'm just using the law of sines, right, this ratio, to find x1 and x2. So we have that big side is 100, and that corresponds to over here to this angle, right? They're directly across from each other. So that's why I do 100 over sine 60 equals x1 over sine 30, because that's this here. Sorry, it's getting messy there. All right, so we just solve for x1 and x2, and then we can go ahead and add those together. Okay. Perfect. And that'll give us that big X, which is exactly what we want. Great.